38 by 32 TPI, ME model engineering. Alright. Hello and welcome back to the shop. We're in the new year now. 2nd of January now. It's about, 25 to 11 in the morning. And I've just come in the workshop. It's real cold outside. Got a bit of a snow flurry this morning. I think we're going to have some snow this next few days. And plenty of frost anyway. But I've got my diesel heater on. It's been on about half an hour now. It's cold in here. This is absolutely freezing. This is my Tailstock Die holder, and this is the die that we talked about in the last video when we had that problem with the undersized thread on that bronze gland follower that we were making for our vacuum brake cylinder. And I remember one of the comments from one of our viewers, maybe a couple of videos ago, I can't remember now, was the problems with condensation in a workshop. There's no condensation on anything in here. There's certainly no frost, no ice on here, even though it's cold. But interestingly, I've got on the thermometer by the door there, it says 5 degrees. We're fortunate the sun, because the back of my house here, down the garden, it faces south, and where I live is a pretty flat area. There are some slight hills and things, but it's a pretty flat area here. The Pennines are not far away, only over there. And of course, probably about 30 miles that way, we've got the Welsh Hills. But in this particular area, it's quite flat. So you always get, if the sun's out, you always get the sun. It always comes around. Starts off obviously over there to the east, and it comes around, all the way around to the west where it sets. So we get the sun pretty much most of the time. But the other thing is, it's a very sandy loam. The soil is very sandy loam. I've been down 2 spades when I've been digging my garden over 2 spades depth, and it's still, you can still see the sand in the soil, and it drains away incredibly well. I dug one of the vegetable patches over last week, turned it over and put some compost on there just to let it set over the winter, so it gradually soaks into the soil. And I was digging it over, and it was like dust in places. Yeah, we'd had a lot of rain the previous week. It just drains away so fast, so we're not holding much moisture in the ground. And also as well, when I had this workshop built, I had the concrete base insulated, so it's got, I don't know what they put in there, but I had it insulated to try and stop the cold coming through in the damp. And I've insulated the walls, and we sort of vaulted the roof as well, which has made a big difference. It's made a big difference. It's a lot more comfortable in here than what it would have been. I wouldn't like to be in here if it was, unprotected from the frost and cold and damp and that. It wouldn't be very nice at all, and the machines in here would suffer. The other thing is, most of my machines are absolutely covered in oil. There's oil in everything. That's one thing you notice. As soon as you come in through the door, the first thing you notice is the smell of old oil. You know, when you go into an old workshop, you'll go in and think, oh yeah, I can smell the old oil. You know, that's what you can smell when you come in here. But anyway, I thought I'd come in here and I'm just going to have a look at that problem that we had with the die. And I've got it here. I've just been looking at it. What I've done now is I've opened that die up as far as it'll go. Let me put it here. Can you see now? So the middle, you've got on a die stock holder and also on tailstock die holder. Let me just grab an ordinary conventional die stock holder here. Not an expensive one, a cheap one here. You can see you've got three screws there, haven't you? Yeah. The central one always fits where the little nick is, where the slot is. Yeah. Then you'll always find that that's tapered on the end. That little screw is tapered on the end. And that fits into the slot. So what it does is it opens the die up. You can open and close the die. You've got to work that in conjunction with the 2 clamping screws. Yeah. So never just put a die in and tighten them down. Always adjust it first to the size that you want it to be. Yeah. So for example, if if you're going to be thread cutting, I don't know, maybe a piece of aluminium or something like that, something soft, you could perhaps do it in one go with your die. But if you're going to thread something like, you know, high-speed, well, not high-speed steel, silver steel, which is the old name was stub steel, what you might want to do is say, I'm going to do that in 2 cuts, I'm going to rough it off, and then I'll readjust this die to do a finishing cut as well. So the choice is yours what you do with them. But what was interesting was, of course, we know that this has actually cut the thread 10th thou under. It's 10,000ths of an inch undersize, and we turned it bang on 375, which is 3/8 of an inch. So somehow there's a reason why it's undersized. Now, could it be that the tailstock die holder is offset one way or the other, so it's cutting predominantly on one side somewhere? Is it cocked over? Well, we don't know that. But one thing I do know is that the tailstock on my lathe is bang on. That's bang on, that's true. I do know it runs true. There's nothing to indicate to me that there's an error with the tailstock. Is the die concentric? And that's a possibility, isn't it? We don't know, because we've got no way of measuring that. We've got no way of knowing. But I did think as well, what's the core diameter of that? And how does it relate to what it should be? Now what we can do is we can get our vernier and we can have a look in the engineer's book, that red one that I showed you the other day by Tubal Kane. We can have a look in there because he's got all the data in there for the model engineering threads, of which these are. And I believe that the thread form is the Whitworth thread form on the model engineering threads. I could be wrong with that, but I'm pretty sure they are. Let's have a look at the book. We'll go over to the bench, we'll have a look at the book, and we'll see what it says, and we'll see if we can measure measure the core diameter of the die. Let's see what it starts out at. That'll be really interesting to know. Unfortunately, we've got four flutes, so we can measure directly across. If it was a 3-flute one, we couldn't do it, or unless we had some kind of a gauge we could drop in. And then you'd think, well, I don't want to put a gauge in there because it'll get jammed and damaged and things like that. But anyway, let's go over to the bench and have a look. Right, I'm standing by the bench now, and obviously you can see the sun shining on me. That's why I put you there. If I put you on the other side there, then you'd get the sun and glare you out. But anyway, I'm looking at my Model Engineer's Handbook by Tubal Kane. You can see that there. I showed you this last time. And it's got some really useful information in this book, as it's great. So if you're into model engineering, anything of this nature, it's a good little book to get hold of. I've no idea how much it costs nowadays. I've probably had this about 10 years. But anyway, it's got some really good information on threads, obviously. And you can see this page here. It shows a table with the different threads. We've got Whitworth, BSF, we've got model engineering threads and unified threads. Alright, so if I look down for 3/8 of an inch, now if I could see it, 3/8 of an inch, and I go across to 32 TPI, it tells me my core diameter is 335. Alright? 335. So remember that. What we're going to do is we're going to put our extraordinary glasses on. 335 we said, didn't we? Now I wonder if I can measure this. Can I measure the core diameter? Let's have a look. We've got our die in there, yeah. I'm going to measure straight across. If we can. 3, 25, 30, 35. Now that's about 3.6. So yeah, 335. We've just verified there that we've got the right core diameter. So that eliminates that little problem. So we've got to say to ourselves, what else could cause this problem? And don't forget that die now is opened up to its maximum diameter. Maximum diameter. It can't go any more because of the tailstock die holder. So I've opened it up to its maximum diameter. I never had it that far open when I was doing it before, when I cut that thread last time. So 335. So what does that give us? That's 40,000, that's 20 thousandths depth. Let's just verify that. Core diameter, where are we? 3/8 of an inch. 335. Well, if it's 375 outside diameter, that's 40,000 in, so that's 20 thousandths in feed, or 20 thousandths depth of thread. It's not much at all, is it? So that's why it's an easy job to turn that on the lathe if we wanted to. But it's, you know, it seems that you've got all these dies in your boxes over there. You think, well, if you can't use them, what's the point in having them? And they really are useful to get in. Sometimes you just can't get in with your turning tools. It's not practical to do that, or your thread cutting tools. So having a die is a really useful device. But anyway, what we're going to do is we're going to go to the lathe and we're going to get ourselves a test piece set up, and we're going to do a few little tests to see what we can achieve with this. Can we get it better than what it was? Can we get it acceptable? Or do we have to come up with a complete new system for using dies? I don't have anything like a Coventry die head or anything like that. I mean, they'd be great, but probably be too big for my kind of lathe. And not many of them about these days. But anyway, let's go over to the lathe. Let's get ourselves a test piece, put in the chuck, and I'll use a piece of bronze, because we've got bronze in there now, or a piece of brass, whatever, and we'll see how it cuts. So this tool cuts bronze beautifully. Beautiful. We'll zero that out. And let's just touch off there. We'll just take off 10, which will be 20 off the diameter. We could use the automatic feed. Should we do that? Let's use the automatic feed. There you go. It's giving us a nice finish, that is, as well. It's cutting nice. Let's measure that. Probably next week I'm going to have a chat with one of my suppliers about the best type of cutting fluid for bronze. I can't quite remember what it's supposed to be, but I'm sure there's some stuff which is ideal for bronze. Right, where's the micrometer? Here it is. I don't really like cutting it dry. It can be very tough, bronze can, but that's nice. That's beautiful finish, that is. Magnifying glass. What we got here then? We've got 0.408. So what we got? 32 come off. 33. 33 to come off. We'll just take another 10, I think. A bit too much there. There you go. All right. You've got a nice steady speed there as well. We're not going too fast. Bronze doesn't like too fast. Right. Let's check that. My fingers are freezing. That's a problem when you're in your workshop. You know, if it's too cold, it's not very comfortable. There you go, 15,000 to come off. 15 thousandths. So we can probably do a That's 0 that. Let's just do a 7.5 and take it in 1. Let's do that. Let's see what it's like. When you've got a nice sharp tool, what you put on you normally take off. If you've got a blunt tool, your dimensions are going to be all over the place, and so is your surface finish and shape and form of your component as well. Let's have a look what we've got. There you are. There you are. Can you see? We're just 1 under, which is ideal for a thread. Alright. Let's get set up for doing the threading. Well, we'll put a chamfer on there as well. I'll put a chamfer on there and we'll get set up for threading, and I'll show you what we're doing. Alright, we've got everything set up. We're on jog, it's in forward, clutch is engaged, so when we press that button, the start button, it moves, and then when we let go it stops. Alright, let's just have a look then. Let's just reverse that, take the chip, that should be enough. First thing we'll do is we'll measure the diameter, eh? Should we do that? Get all the chips out of the die. Yeah. Right, now let's see. Let's see. That's 7 thousandths under, that is. It's still way under, isn't it? It's still cutting too much. Alright, I've just been in the house and I've been reading through one of the other books. Okay, can you see that? Yeah. Model Engineer Workshop Manual. George H. Thomas. Okay, he's got a section on here on dies and die holders, and he made a lot of his own tools and equipment. Very skilled, very capable engineer, toolmaker. He's no longer with us, as many of these people have passed away now. But left some great information for people. And it's interesting to see what he says about dies and die stock holders and things of this nature. And he made all his own stuff. He made his own die stock holders and tailstock die holder and other things. But it's interesting about the dimensions. I've been checking the outside diameter of the die, checking the bore diameter of the tailstock die holder. Got a conventional die stock holder here. I was checking that as well. What he's saying is all the die holders shown in the drawings are made with recesses about 15 thou larger than the nominal size of the die, which should be +0 to -0.005, so 5 thou under, so 0 to 5 thou under. That's what your split die should be, or your solid circular die. This provides a little space for centralization movements through the four holding screws. On his tailstock die holders, what he did to locate the die central, he drilled and tapped 4 holes. He drilled and tapped 4 holes, so they were all at 90 degrees, so that meant that he could centralize his die. And the reason for that, it's very interesting. If you look at our split circular die here, you can see that there, can't you? We've got our split circular die, and the split's just at the top here. So as you screw the screw in, it's typical of that, isn't it? I'm going to shut this vise because the jaws have a habit of falling out and irritating me. Right, as you turn this central screw in here, you open the die up. But as you open the die up, what happens is it opens up, it's like a clamp, it opens up like that. It pivots about the solid bit at the back. And so what happens is that the diameter is no longer true about the center line. And what you have to do to compensate for that is offset it. So you have to offset it. And that's what he's talking about. So he has 4 screws and he can move it where he needs to. And what he was saying is that normally what would happen is when you fit the die into the tailstock die holder, it was common practice then to do a test piece in the lathe to centralize that die to get the die cut into the right size. Otherwise it won't. So we don't think about that. We just think, oh, I'm doing a, you know, for example, the 3/8 by 32 teeth component. Just put the die in, tighten it down, whatever, and then do the job. And then 2 minutes later, or 20 minutes later or whatever, we're doing another component and it's 1/4 inch by 32 or whatever it is. Put another die in, tighten it up. No, what he's saying is you've got to spend the time and set them up. So what he did is he made his own individual set of die stock holders, tailstock die holders. He made the holder, obviously, and he made the piece that goes in, obviously the piece that goes into the tailstock, but he made the individual set of holders for each of his dies that he used, and he typically used between 0 and 14 BA and the model engineer dies, which were very fine threads. So he made them, and what he did then is he centralized everything on his lathe, set them, and then he just put them back in the box so they were ready for use when he needed them. And that way he hadn't got to mess about trying to set things up. They were all set and set ready. So what I thought I would do, just as an interest, just to see, is I've checked this die. Obviously the die as it stands now relaxed, it's about 5 thou under on the core diameter, which is okay. I'm going to open it up and I'm going to its maximum diameter in this conventional die stock holder. Yeah. And what I'm going to do, I'm going to see if I can cut the thread in the lathe. And what I'm really interested in is the outside diameter. What I'm not interested in is this wandering line. I'm not too worried about that. I want to see if it cuts any better, because this is free floating if you think about it. It's completely free floating. So it'll be interesting to see. And it's always important when you put a die in to make sure that the letters are on the outside, so that's facing the work. So it goes on that way, not the other way. So we'll go over to the lathe and we'll have a play around with this, and let's just see what it does. Just all this adds is to prove the theory about this being off center is the problem with the undersized threads. That's what we're interested in. So let's go have a look. This is our last pass now on our little test piece. Let's go. I've just put a bit of cutting oil on, just to help. zeroed the Y. Okay, there we are. There we are. Right, let's have a look what that looks like. .375 we're after. There you go. Can you see 375? I think that'll be good enough, eh? Because it's such a fine thread, we really need to get it as close as possible to nominal size. Right, take this tool out. I'm going to use a thread cutting tool just to cut the chamfer. Alright, I've sorted the speed out. I've got everything set where it needs to be, but we need to be careful. I'm going to do it by hand to start it up. Well, I can't do that, can I? Obviously it's got to be power fed then. This is it's too big. So if this is going round, it's going to hit the bed there, isn't it? So we've got to keep the pressure on. I'm just going to put something in. I don't want to damage that. I don't want to damage the bed. Can I put that in there? Yeah, that'll do. I don't want to damage my bed. Right, let's just see what happens. Let's engage the clutch, don't we? That's not cutting anywhere near as much as it was before with the tailstock die holder. Alright, let's just bring it back and have a look. Let's put it in reverse. Alright. It'll be interesting to see. Well, look at that. 375. It hasn't moved at all. Can you see that? No, that's really interesting, that is. So technically that die in the conventional die stock is free floating. And all I did was centralize it about the center of the bar until it felt right, and then I fed it to. I might use this, even though it's not, it does slightly, you see slight movement in it, but it's given us a much better diameter. That's bang on. That's exactly why it was when we turned it. So it's 3/8 of an inch, and that's what we want. It's not undersize. So our thread's going to be pretty much on size there, and I'm happy with that. Just using the die stock. What I might do is make sets of die holders that fit in here. We'll make them so that we've got, you know, adjusting screws, so we can centralize dies and things like that, and then leave them dies in the holder and then just put them in here, so there'll be a good fit in there. Just push them in. Just tighten it up. But that's not a job for today. And we found out what our problem is. It's not, the die's not being on center. When we open it up, expand it, it's not on center. Right, I think what we need to do is to make one of these land followers and fit it in and have a look what it looks like. Right, we'll start on that, eh? Well, I'm just turning the hexagon bar down now. Just faced it off, zeroed the x-axis. think if we just let it do a spring pass, go back to the 0, because it was on 0, let it do a spring pass. In fact, it's a thought, isn't it? If we left it slightly over, when we run our die down, it'll actually it should do the outside diameter as well and true it all up. Do you know, that's a thought. Should we try that? Let's just do that. Right, are you ready? Let's see what happens when we do this, eh? Will it work, won't it work? We're going to find out, aren't we? Yeah, it's cutting. Oh, I'm just going to finish that by hand. Just pull it, go and pull it round. I'll just take that out. I want this to be threaded all the way, don't I? Right. See, I'm just pulling it round so the die goes up against the shoulder. I didn't want the sheen to... There you go, it's up against the shoulder. There you go. Alright. Just move this out of the way. Shift that. And we'll see what kind of a thread we got. We've 2 thou over on diameter, remember? So maybe the die has corrected that. Who knows? It's taking a lot less than what it was when it was cutting in the tailstock die holder. It's a lot better than what it was. That was awful, that was. Not very good at all. There we go. Alright, let's see what our base is like. There's some slight movement there. That's nowhere near as bad as what it was. I'm going to measure the diameter of the thread as well. We were 2 over, weren't we? Well, that's interesting. That's 1 over. Can you see that? 1 over. I think that's probably as good as it's going to get. Because there could be errors, as we said. There could be errors in this when we were tapping this. And with it being such a fine thread as well, it sort of exaggerates any problems. So right, we're going to leave that as it is. That's our nice little method that we've come up with, and we know why now we're having a problem, because we can't centralize the die true with the work in the tailstock die holder. So we need to start thinking about this. Is there something we can do which allows us to move this whichever way we want? Or do we have to make inserts, die holder inserts in here, which have got the die preset one way or the other way, so that it's central, and we just put the holder in here, and then it's always lined up in the same spot. You tighten the same grub screw and it's perfect. And then we leave the dies fitted into the holders. Alright, let me get sorted out what we're doing now. We've got to do some drilling, reaming and some parting off. I've got the parting tool in now. I'm just going to zero that on the end. Bring that across, and it's 1/16 of an inch thick. So we're going to go 62.5. There you go. That's then your 0. So that side of the blade should be lined up with the at the end there, and then we've got 3/8 and 3/16, 9/16, which is 5/625. So we got 5, 6, 2, that'll be fine that well. We'll lock this. I've zeroed this position now. Because what we're going to do, we'll go in so far with this, and then what we'll do, we'll come out and we'll have put the chamfer tool in and just chamfer the back there. Right, let's have a look. I'll just speed that up a touch, I think. Right. It's the first time you would have seen this parting tool being used, this rear tool post with these blades I don't like. Anyway, we'll have a look, see what it's like. There you go. No drama, that's what we want. See the advantage of that rear tool post. Makes a big difference. If I'd put a conventional tool in here because of the overhang here as well, it would just snap off and cause a problem. Damage the work, damage the machine. I don't fancy doing that. Alright. Switch that off now. So there you are, that's our part. Yeah, that's the gland follower. You can see it looks quite nice. Just got to deburr this here and then that's it done. And we'll check it in the bottom half of the cylinder. Alright, well there's our gland follower. Yeah, you can see that now. It's actually a pretty good fit on the threads. Happy with that. Seems a lot better now. Whether it expanded or not, I don't know when it was when we reamed it. God knows. It seems to be pretty good now. I'm happy with that. Now I've got a piece of rod that goes through. So you can see that now, eh? It's exactly how it should be. All we need to do now is make 2 more of them. And that's another aspect of our project complete then. I don't think I've got the material there though. I've got enough probably for 1. I don't think I've got enough for 2. 1, maybe 2. We'll see. We'll see. I'm just having a quick look then. We'll see. Anyway, I'll get on with them and I'll do them, but it might not be today now. It might be on another day. I'm not sure now. But just going back to the thread, I've had that problem before where the threads were way undersized on, using the tailstock die holder. And I remember talking to one of my friends down at the Severn Valley Railway. I was talking with John, and he was mentioning about that. And it's only just come to me now, but he did mention about things being off centre with the tailstock die holder when you expand the die. So obviously John's had experience of that, so I just thought I would mention that. But I like that, that's pretty good. That's looking okay. But anyway, I'll see you next time, and thanks for watching.